Now at this point, we're going to we're working towards a couple of important limits that we'll need to talk about, and to see all the reasons why these limits work the way they do. We want to start out by developing a formula for the area of a sector. Lots of times this is done in a pre-calculus class, but we'll do it here, even if you've already done it. So you just bear with me if this is old business for you. All right, a sector is a piece of pie, and let's suppose that we have a circle with radius r, and a sector whose central angle is theta, and the area of this sector is A. That is the area that's shaded yellow is A. All right, notice what happens here. The thing is, if I would double the size of the sector, or the size of the central angle, all right, I'd have twice as big of a central angle, I'd have twice as much area, but notice that the area to the central angle ratio would still be the same because the 2's would cancel. If I would triple the size of the central angle, all right, I'd triple the size of the area, the 3's would cancel, and I'd still have the same ratio of area to the size of the central angle, and we could keep on going if I quadrupled, if I quintupled, and so on. And so the point is that the area to the central angle is a constant ratio, no matter how big that central angle is. So what we want to do is we want to take a specific thing. All right, suppose we have the area and central angle of one sector, and then let's consider another sector being the entire circle. The area and the central angle are known for the entire circle. So let's see what this would mean in this circle. Suppose, first of all, that we measure the area in degrees, or the angle in degrees. So this central angle, in that case, we'd have to have measured the central angle also in degrees. All right, and if we looked at this area of that sector divided by the central angle, again measured in degrees, that would be equal to, well, the area of the circle is pi r squared, and the central angle would be 360 degrees. Then a formula for the area of the circle would be, or for the area of the sector would be A1 is equal to pi r squared theta 1 divided by 360 degrees. Theta 1 would also be measured in degrees. So this is the formula if we measure things in degrees. Right, if we measure in radians, if we measure this in radians, right, we'd have the area over the central angle of the sector, A1 over theta 1, is equal to the area of the circle, pi r squared, over 2 pi, which would be the radian measure of one revolution, of 360 degrees, the central angle for an entire circle. And notice here that the pi's cancel, and then if I multiply through by theta 1, the area of the sector would be given by 1/2 r squared times theta 1, assuming that we measured theta 1 in radians. Now, of course, this formula is much nicer than this one, so what we'll do is we'll just say that we'll make this a rule of thumb that we'll measure the angle in theta. All right, so we'll let radians, I should say radians be the standard angular measure, and if that's the case, then the area of the sector remember that's the area of a piece of pi, is 1/2 r squared theta, all right, where theta is the central angle of the sector. Okay. All right. In particular, in the unit circle, all right, r is equal to 1. So what we have is that the area then is 1/2 theta. The area of the sector is 1/2 the radian measure of the central angle.